Good morning, good afternoon, and good evening. This is review for test number 3, I think. Alright, so I don't remember all the equations, but these are the ones I remember, so I just put them on the side. And yeah, let's get started. Alright. An 80-kilogram skier is being pulled by a boat with a force of 220 newtons, causing the skier to accelerate at 1.8 meters per second squared. Find the drag force, so we're solving for force drag on the skier. So we don't have any angles here, so it's pretty safe to assume that it's going left and right. So if we made a force diagram, we got force drag going this way. We have force normal going this way. Force gravity. Force normal. And we know the mass is 80 kilograms. And the acceleration of gravity is -10, so we can say the force of gravity is just 80 times 10, or 800. So we're going to put 800 newtons here and 800 here. So we have acceleration as 1.8. And the boat is being pulled with 220 newtons, so let's put 220 on this side. So the total force equals mass times acceleration. And we have both, so let's do total force equals 80 times 1.8 equals, and I gotta look this up. So that's going to be 144 newtons. So that means to the right, it's moving with 144 newtons. But if you see, the force normal is 220. So what we're going to do is subtract. And that becomes 76. So force drag equals 76 newtons. Sorry, I'm a little sick. All right, a 2,000-kilogram car is slowed down uniformly. That's important. From 20 meters per second to 5 meters per second in 4 seconds. Determine the average net force on the car during this time. How far? So we're looking for how far, so delta x. And the average net force, so we're going to take that as total force equals question mark. So first, let's draw the force diagram. So we're going to go force normal, force friction, force gravity, force normal. So we have 2,000 kilograms. So again, 2,000 times 10, 20,000, both ways. All right, now that we have that out of the way, we can take a look into this. So first thing we have, it slows down from 20 to 5, so we have the initial velocity at 20, final velocity at 5, and we have the time at 4. So what we don't have, and we have the mass, so 2,000 kilograms. So let's look at the equation. Total force equals mass times acceleration. And we can fill in what we have so far. So we don't have total force, but we have 2,000 A. And with this stuff, we can plug it into the equation. VF equals VO plus AT. And what that's going to do is give us the acceleration. So let's plug everything in. 5 equals 20 plus 4A. So 4A equals -15. Acceleration equals -15 over 4 meters per second squared. So now with that, we can find the total force. So plug that in. So this A becomes -15 over 4. So we get the answer as total force equals negative 7,500 newtons. So that's for the first part, so I'll just call that A. For the second part, B, delta X, if we look at these equations on the side, we have all this stuff, and therefore we can just plug it in there. So delta X equals 20 times 4 plus 1/2 times negative 15 over 4 times 16, which is just 4 squared. And after plugging all that in, we get 80 plus 0.5 times negative 15 over 4 times 16 equals 50. So 50 meters total. So that's part B. And just to make it a little bit more clear, and B, A. All right, little break. We're back. Some baseball pitchers are capable of throwing a fastball at 100 miles an hour. So we got to make that into meters per second. So let's just do that now. We'll do it over here. So 100 miles an hour times 1 mile over 1,600 meters times 1 hour over 60 minutes times 1 minute over 60 seconds. So cancel, 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 cancel. Now we're left with meters per second. So let's do this math. .44 repeating meters per second. Okay, now let's take a look at this. So we can just replace this with 44.44 repeating. So some baseball pitchers are capable of throwing a fastball at 44.44 meters per second. That's our velocity. So velocity equals 44.44 meters per second. So sort of looking through this, honestly, without reading the whole thing, we can just see determine the average net force. So we're solving for total force equals question mark. And just the equation, mass, acceleration. So distance of 1.5 meters. Let's take delta x, 1.5. Now we have mass, 0.15. So mass equals 0.15. So we just need 0.15 times question mark. So we can assume that the initial velocity is going to be the speed of the pitch, because it is true that the ball will accelerate through the air, but we have to realize that it's going to be slowing down as soon as it hits the glove. So we're sort of taking it from that time it starts to the time it hits the glove. So in this case, we're going to take this as VO, and we're going to take VF as 0. So from here, we're going to do VF equals VO plus AT to solve for the acceleration, which is what we need over here. And with that, we're going to do 0. Oh, no, sorry, we don't have the time, do we? So let's see what we can use. Oh, yeah, I already wrote it. So VF squared equals VO squared plus 2A delta X. So let's take 0 equals 44.44 squared plus 2A delta X is 1.5. So let's take that, and we get acceleration equals squared over 3. So we get negative 658.436 meters per second squared. So we plug that in, multiply it with 0.15, and we get times this. Total force equals negative 98.76 newtons. So that's going to be our final for this question. And I'm just rounding to the 10th place. All right, back again. I already read this. 25 degrees. Let's waste no time. Friction, mass, tension. Okay, so I'm sort of trying to put the obvious in here. Make it nice and easy. Force friction, 15 newtons. So what do we need? Oh, we need the acceleration. So we need the acceleration. Acceleration equals question mark. So in order to find this acceleration, we're not given much. So total force equals mass acceleration. So we need to find what this is, subtract it from 15 newtons, or subtract 15 newtons from this, I should say. Then multiply that by 100. So just move it 2 decimal places to the right. Or sorry, we have to divide it by the mass to find the acceleration. So move it 2 decimal places to the left. So we kind of have everything we need here. So we're just going to call this x and this y. So cosine of 25 equals x over 120. Now let's plug that in. 25. So this number x equals 108.76. So let's take that number, which is going to be the force going that way, subtract it by 15. So 93.76. So that's total force. Now we got the mass, 100 A. So this number over 100 equals 0.937 or 0.94 meters per second squared. Alright, I messed this one up pretty bad. So I want to fix it now. So I gotta redo this entire thing. I don't want to give anyone false information. Or actually, I can leave part of it. And we can redraw this diagram. Force gravity. Force normal. And this going this way. Friction. We got normal force. We got gravity. And we made this one straight line here. Split this up into the x. Or, mess it up again. Just think about, like, this one's going to be the biggest one. And 60 kilograms, so 600 newtons. Sort of want to make this the y. And this the x. There we go. 90. So this will be the y, this will be the x. And let's find these x and y values. Oh, and we gotta put in this angle. So we can say this is 35. So sine of 35 is going to be this x over hypotenuse. So we can say that this is 344.15 newtons. And we can say this y if we do cosine. So cosine of 35 times 600. Let's call it 491.49 or 491.5. Either one works. And we're looking for the acceleration. So acceleration equals question mark. So if we look, the skier is moving in this direction. And our gravity is taking us this way too. And the total force is going to be this force going this way minus that friction. So we have the coefficient for the friction. 0.08 times 344.15. So we got to take, now we have 27.53 as this friction. Or actually, even that's off. Because you got to think about it like, take the perpendicular value for the force normal. So we're going to have to take this one, which I guess we're going to take as this. Okay. So times 491.49. And now we get the force friction is 39.32. Yeah, kind of forgot that for a second. So subtract that number we just got, the friction, from our force x, so 344 minus this 39. So now we have the total force. And total force over mass equals acceleration. So let's divide it by 60. .08 meters per second squared. And that's all she wrote. Good luck.